Hi GOR, this is Unit 2, Lesson 6, and today we're going to talk about composition of rigid motions. So basically a composition of rigid motions is just going to be one rigid motion working off of another. So in exercise 1, I have triangle 1, 2, 3, and 4, and I want to sort of figure out what rigid motion took place to go from the first one I'm going to do triangle 1 to triangle 2. So from triangle 1 to triangle 2, did I reflect that? Did I rotate it or did I translate it? So that's the question. Now a reflection is a flip. So did I flip it over point A? No, because you could see that this triangle is turned. All right, like if this was QRS, this says QRS right here. Let me get my pen. QRS. You can see that Q is now down here. That's sort of like where that angle is. R is up here and S is up here. So I rotated this about point A. So if I connect S to point A and S prime to point A, you can see that I did a rotation. So I did a rotation about point A. To go from triangle 2 to triangle 3, now that looks like I exactly flipped it because this looks like Q double prime, this would be S double prime, and this would be R double prime. I just reflected that over line BC. So I did a reflection over line BC. And to go from 3 to 4, you can see I just shifted it up. I did a translation. Now translation, usually if I'm on a graph, I tell you the points, the number of points, like I translated it, 4 to the right and 3 up. I can't do that here because I don't have a graph, but I do have this nice vector. So this vector is showing me the direction and the length of the translation. So I translated it, so I can write that as translate it, and then I do the vector down here instead of writing the number of points that it translated. Okay, so a composition. This is all compositions. So first I did a rotation, then I did a reflection, and then I did a translation. It's when a series of rigid motions takes place with one rigid motion building off of the other. So it's when a series of rigid motions takes place with one rigid motion building off of another. The symbol that I use for a composition is this little tiny open circle. So that's going to be between the two rigid motions. And another important thing is when performing or writing a composition, you always work from right to left. So I'm always working from right to left. So what exactly does that look like? The one that I have up above, let's write that with some symbols so you can see it. The first thing I did is I did the rotation about point A. And I measured it. I know you guys don't have a protractor, but it was about 150 degrees. So I use a capital R for rotation, about point A of 150 degrees. That's the first thing I do, so that gets written all the way on the right. Then I did a reflection. Now a reflection, I use a lowercase r. I reflected it over line CB. And then I finally did the translation, and I did a translation vector DE. But you can see the first thing that I did is a rotation, and that's all the way on the right. Another way to do this is to use parentheses instead of that symbol. So again, I did the rotation first, and that was about point A of 150 degrees. Then I did the reflection over line CB. And then finally, I did the translation. And just like math, parentheses, you're going to work inside the parentheses first. So that would be another way to write the composition that I did above. Okay? So let's look at a point, an actual point, just to do it. That will be a little bit easier, I think, to see what's going on. So in exercise 2, find the coordinates of x prime, the image of x, which was negative 2, 5, after the following composition. Now, when I was doing this, typing it up, they didn't have the exact circle, so this should just be a circle. That was the closest I could get to it, though. So I'm starting with point x, which is the point negative 2, 5. I'm always doing the thing on the right first. So first I'm going to do a reflection over the x-axis. Now remember my rule for a reflection over the x-axis, the y changes. So I leave the x alone, the y would change its sign. Now I'm going to take that and I'm going to do the second transformation, and that is a translation. So the second thing is a translation of negative 2, 1. So I'm going to add negative 2 to negative 2, and that's going to give me negative 4. And then I'm going to add 1. Negative 5 plus 1 is negative 4. And this is my final answer, so that's why I called it x prime. All right, so how about you guys try 3? You can pause the video and try it. B is the point 2, negative 4. And I'm doing this composition. I always start with the thing on the right. So first I'm going to do a rotation of 90. If you need to look up your rules, look up your rules. But remember, rotation of 90, you change the sign of the y goes in the x position, and then the x goes in the y position. And then I'm going to do a reflection over the line y equals x, which just means that you flip-flop the x and the y. So this 4 and 2 are going to get flip-flopped, and it'll be 2, 4. And my final point, the image, is called B prime. All right. Exercise 4. Pentagon ABCD is pictured to the right. L and M are lines of symmetry. Evaluate the following. So basically, I'm going to start with point E. So let me find point E. Point E is here. And I'm going to first reflect it over line M. So here's line M. I'm going to flip it over line M, and point E is now going to become point A. Then I'm going to take point A, and I'm going to do the second transformation, which is to reflect it over line L, and I will now wind up at point C. So I just wanted to show you one that was a little bit different. I can also do that same thing with a line. So let me erase all this so we can start over. Oops. Okay. So starting over, let me pick a new color here. I'll use the purple. That looks too similar. Let me use the green. All right, so I'm starting with BA, so let me find BA. BA is right here. I'm going to reflect it over line L. So here's line L. If I was to take BA and flip it over line L, I now have BC. So BA is going to become BC. And now I'm going to take that and reflect it over line M. Here's line M. Let me get this color. So I'm taking line BC and I'm reflecting it over line M, and I would wind up here at CD. And that would be my final answer. All right, exercise 5. The coordinates of ABC are A is negative 2, 2. So I'm going to plot that. There's my A. A is negative 2, 2. B is 3, 5. 1, 2, 3, 4, 5. And C is 4, 2. 1, 2, 3, 4. 1, 2. All right, so there's my triangle. Graph and state the coordinates of A double prime, B double prime, C double prime, the image of ABC after a composition. So first I'm going to do a translation of negative 4, 0, and then I'm going to do a reflection over the x-axis. So these are my original points. A, B, C. I like to write them down because I'll show you I'm going to sort of build off of them. So the first thing that I'm going to do is I'm going to do this translation. So let me grab another color. So I'm going to subtract 4 and add 0. So if I subtract 4, that gives me negative 6, and add 0. That does nothing. Subtract 4, negative 1, add 0. Subtract 4, add 0. Okay, so I'm going to plot these. These will be the A prime, B prime, C prime. So negative 6, 1, 2, 3, 4, 5, 6, negative 6, 2, negative 1, 5, and 0, 2. Now notice it's the same shape, same size. I've just shifted it over. I sort of missed right there. And then I'm going to do the final thing that they wanted me to do. Grab this purple. I'm going to do a reflection over the x-axis. So when I reflect over the x-axis, I change the y. And see how I'm just building off of this. So change the y. Change the y. I leave the x, change the y. Leave the x, change the y. All right, so then my points are going to be right here. This will be A double prime. This will be 1, 2, 3, 4, 5. B double prime. And 0, negative 2. C double prime. Should look like I just flipped it over the x-axis. This is actually a glide reflection. So I'm just going to define that for us. A glide reflection is a specific kind of composition. It's a composition where I have a translation and then a reflection. Okay, so it's a translation and a reflection. The reflection has to be in the same direction as that translation is, though. All right, and then I'm just going to look at some and I'm going to write the rule for the composition. All right, so looking at this 6, using the diagram, write the rule of the composition. I did 2 things. So this is kind of hard. I have to figure out what I did first and then what my final image is. Like they're not drawing the in-between one, so that's why it's hard. The first thing that you should ask yourself is, did the orientation change? If the orientation changed, then I must have done a reflection. So did the orientation change? That's my first question that I'm asking them. If yes, you did a reflection and you just figure out what that reflection is. So let's look at this. This is DEF. So if I go clockwise, it's DEF. If I look at the image and I go clockwise, it's DFE. So yes, the orientation changed. I must have done a reflection. So you're just going to look at the most obvious reflections. Did I reflect it over the x-axis or did I reflect it over the y-axis? Well, look at your picture. The original image, the D's on top, and then in the new one, the image, my D's on the bottom. So I must have reflected this over the x-axis. And I'm actually going to draw it for us. If I reflected this over the x-axis, it would look like this. Let me just get this right. Okay, so this would be my E, this would be my F, this would be my D. Now, look at this. It's really, really similar to this. Everything's in the right spot. All I have to do is a translation, so I'm just going to count. I go 1, 2, 3, 4, 5, 6 to the left and 1, 2, 3 up. So I did a translation of negative 6, 3, and that's my answer. So that's how you sort of play around with these. Look first to see if a reflection took place. If a reflection took place, then after that, it's usually just a translation to get it in the right spot. But you want to first everything to, make sure everything's good. Like look at B. I've got Q, R, S. So Q's on top, S is on the left, R is on the bottom. Look at my image. Q is still on top, but the R is now on the left and the S is on the bottom. That means I must have done a reflection over the y-axis. So here's my R, and then my S is going to be down here, and here's my Q. Oops, 1, 2, 3. Sorry, my Q is right there. Now look, everything is it's perfect, but I need to shift it down. So I did a reflection over the y-axis, and then let's just figure out what my translation is. I didn't move left to right. All I moved is 1, 2, 3, 4, 5, 6, 6 down. So that's 0, negative 6. All right, these aren't too bad. And And then, of course, there's some that are not on a graph, so we got to look at that. So if this is not on a graph, this might be even a little bit easier. How did I go from here to here? You can see that I just did a reflection. Now, that's the last thing I did. So I did a reflection over what? Because I'm always reflecting over a line. I did a reflection over DE. Now, how did I go from this one to this one? It looks like I just translated it up and to the right a little bit. I can't use numbers because I'm not on a graph. So I translated it by that B prime, B double prime. That's the vector that I translated it over. And then to go from there to there, this last one, I did a rotation. Rotation, I'll use a capital R. I rotated it about point A double prime. Okay. And you guys don't have a protractor. If you don't have a protractor and you're not given one on the regions, you can also just say the angle that you rotated it about. Okay, so I can use this angle. But I did measure it, so I rotated it. Now remember, all my rotations are going counterclockwise. So if I wanted to go clockwise, you can see this is a little bit more than 90 degrees. So I rotated it negative 100 degrees. All right. And in each of these compositions is the image congruent to the pre-image. All right, each of the compositions shown below in parts A through C is the image congruent to the pre-image. Absolutely it is. It's all the same shape, same size. Length and angle measure are preserved. These are all rigid motions. So yes, same shape and same size. They're all rigid motions. And we will continue with this concept of being